For generations, one enormous red star has dominated the shoulder of Orion. Its name is Betelgeuse, and although it appears as a tiny point of reddish light from Earth, the reality behind that glow is almost impossible to imagine. Betelgeuse is a red supergiant, a massive star approaching the final stages of its life. It is hundreds of light years away, meaning every photon reaching our eyes has been traveling through space for centuries. When we look at Betelgeuse, we are looking into the past. The star is also remarkably different from our Sun. Its surface is cooler, which gives it that distinctive orange-red appearance, but its enormous size allows it to radiate vastly more energy than a star like the Sun. If Betelgeuse occupied the center of our solar system, its outer atmosphere would extend enormously far into the planetary region. But size is only part of the story. Betelgeuse is unstable. Its outer layers constantly rise, fall, expand, and contract. Enormous convection cells transport energy toward the surface, while powerful stellar winds carry material away from the star. These processes make Betelgeuse appear to change brightness over time. Astronomers have been fascinated by those variations for generations, because they provide clues about what is happening inside the star. And then, near the end of 2019, Betelgeuse did something that captured worldwide attention. Its brightness dropped dramatically. The change was so obvious that even experienced skywatchers noticed that Orion no longer looked quite the same. Almost immediately, speculation exploded. Could Betelgeuse be preparing to explode? A supernova from a nearby red supergiant would be one of the most spectacular astronomical events humanity could witness. But the evidence eventually pointed toward a less dramatic explanation. Scientists concluded that the dimming was largely caused by material expelled from the star. A plume of gas moved outward and cooled, allowing dust to form and temporarily block some of Betelgeuse's visible light. In other words, the star had not suddenly switched off. It had partially hidden itself behind material it had thrown into space. That event revealed something important about the life of massive stars. Betelgeuse is continuously losing material. The gas and dust leaving the star eventually become part of the interstellar environment. Over enormous periods of time, material released by dying stars can contribute to future generations of stars and planets. The atoms in the universe have a history. Some elements were created inside stars, while others were produced during violent stellar events. So when a massive star loses material, it is not simply disappearing. It is returning matter to the galaxy. Eventually, however, Betelgeuse will reach the final stage of its evolution. Deep inside the star, nuclear fusion progresses through increasingly heavier elements. Massive stars can build elements in layers, with the core eventually becoming dominated by iron. That is where the story changes. Fusion involving iron does not provide the energy required to support the core against gravity. When the core can no longer maintain that balance, collapse becomes inevitable. The result can be a catastrophic supernova explosion. But there is an important detail that makes Betelgeuse even more fascinating. We do not know exactly when that explosion will happen. It could occur relatively soon on astronomical timescales, or thousands, perhaps even much longer, of years from now. And because Betelgeuse is hundreds of light years away, we cannot observe its present-day state directly. The light reaching Earth today began its journey long ago. So there is a strange possibility. Betelgeuse could already have changed dramatically, while the news of that change is still traveling toward us. Every night we see the star, we are seeing an ancient version of it. And somewhere between the star and Earth, its future light may already be on its way. The question is not whether Betelgeuse will eventually transform. It will. The real mystery is when, and what its final moments will teach us about the lives and deaths of the universe's most massive stars. Imagine looking toward Orion one night and noticing that the familiar red star on its shoulder has suddenly disappeared. Then imagine that, months or years later, astronomers announce the impossible. Betelgeuse has exploded. A supernova from a massive star would be an extraordinary event, and Betelgeuse is one of the stars astronomers watch closely because of its advanced evolutionary stage. But there is no reliable prediction that its explosion is imminent. That distinction matters. Betelgeuse could remain in its current phase for a very long time before its final collapse. When that moment eventually arrives, however, the physics will be extraordinary. The star's core will collapse under gravity in an incredibly short period of time. The outer layers can then be violently expelled, producing a supernova and scattering enormous amounts of material into surrounding space. The event would dramatically change the appearance of the night sky. Betelgeuse could become extraordinarily bright, potentially visible during daylight depending on the exact circumstances. But despite the dramatic appearance, astronomers do not consider Betelgeuse a significant danger to Earth at its current distance. The radiation reaching us would be vastly weaker than what exists close to the explosion. Instead of being a threat, the event would become one of the most valuable natural laboratories in astronomy. Scientists could study the explosion across multiple wavelengths. Telescopes would observe the changing light. Space observatories could monitor X-rays and other energetic radiation. Radio instruments could examine material moving through surrounding space. And neutrino detectors could potentially provide another remarkable clue. Neutrinos are tiny particles capable of escaping from the collapsing stellar core and traveling through space with very little interaction. Detecting them could help scientists understand what happens during the final moments of a massive star. But Betelgeuse is fascinating even before its eventual explosion. Its surface is constantly changing. Massive convection cells transport energy from deeper layers toward the surface. The star also experiences pulsations that can alter its brightness and contribute to the movement of material through its atmosphere. Its surrounding environment contains gas and dust expelled during previous episodes of mass loss. Astronomers can study these structures to reconstruct part of the star's history. In this sense, Betelgeuse is more than a distant point of light. It is a record of stellar evolution. Every observation gives researchers another clue about how massive stars live, lose material, and eventually die. And there is something profoundly strange about the way we observe it. Because Betelgeuse is hundreds of light years away, we never see it exactly as it exists at this moment. We see an earlier version. If the star exploded yesterday, Earth would not know until the light and other signals from that event reached us. The explosion could already have happened somewhere beyond our present view. Or Betelgeuse could continue shining for thousands of years. We simply cannot know the exact timing. That uncertainty is one of the most beautiful parts of astronomy. The universe operates on scales far beyond human lifetimes. A star can spend millions of years evolving, while humanity may observe only a tiny fragment of its story. Eventually, Betelgeuse will return its material to the galaxy. Elements created during its lifetime and final stages may become part of future cosmic structures. New stars could form from enriched clouds. Planets could inherit atoms forged inside ancient stellar interiors. And perhaps, unimaginably far in the future, some of that material could become part of worlds where another civilization looks toward the sky and wonders where its elements came from. For now, Betelgeuse remains above Orion. Red. Enormous. Unstable. And still shining. Its final chapter has not yet arrived, but when it does, humanity may witness one of the greatest astronomical spectacles in history. Until then, every time you look toward Orion, remember that the red point on its shoulder is not simply a star. It is a glimpse into the life cycle of the cosmos itself.